In this video, we're going to look at resonance structures and formal charges. And this has to do with Lewis structures again. So when we're writing out Lewis structures, it is possible that we could come up with more than one Lewis structure, or that your electrons could move between different Lewis structures. And this is an idea we call resonance, where you have charge that is delocalized that actually helps stabilize the molecules. And so you can write multiple Lewis structures. So here's O3, and we can have two different Lewis structures for O3. Both are equally as good. Each one of these is called a resonance structure. But the molecule actually doesn't swap between these two. We don't have a double bond that is constantly swapping. Rather, you have something that looks like this, where you have this dotted line that is showing the double bonds here, but it's also here as well. And that's called a resonance hybrid. And you can think of it like dogs. If you combine two dogs that are different, you'll get a hybrid dog. You don't get a dog that sometimes looks like this dog, or sometimes looks like this dog, but it's a hybrid between the two. That's happening with molecules. You get a hybrid. You're never going to get O3 looking like this or looking like this. It looks like this hybrid. But to decide if we have multiple Lewis structures, which one is the best, we have what is called formal charge that we can give to each atom. And formal charge just tells us, what is the charge on this atom if that electron was allowed to have all the electrons surrounding it. And the way we calculate formal charge is we take the number of valence electrons minus the non-bonding electrons plus 1/2 bonding electrons. And you basically want all the formal charges of your atoms to be 0, and for your atoms to have no formal charge if possible. What I mean by that is, let's look at structure A and structure B. So hydrogen. How many valence electrons does hydrogen have? 1. How many non-bonding electrons? Well, it has 0. And how many bonding electrons? It has 2 multiplied by 1/2. Take number of valence minus 0 minus 1/2 times 2, formal charge of 0. Same thing for carbon, formal charge of 0. Same thing for nitrogen, formal charge of 0. However, what if we wrote structure B? So hydrogen, same thing, 0. N has 5 valence electrons. Here we have no non-bonding electrons, 8 bonding electrons, so it would have a formal charge of +1. Carbon, 4 valence electrons, 2 non-bonding electrons here, 6 bonding electrons, formal charge of -1. So although this will equal 0 as well, you have atoms with formal charges of +1 and -1. You want to avoid that if you can, so structure A is the best structure. And so how do you know which structure is the best? One, if your structure has fewer formal charges, they have smaller formal charges, and you have your negative formal charge on the more electronegative atom. So I have 2 Lewis structures here. See if you can use the rules we just learned to decide which atom or which structure is the best. And the answer is this structure on the left. When you calculate all the numbers out, each atom should have a formal charge of 0. While the one on the right, you'll have atoms with formal charges, which is unfavorable. That's it for this video and for chapter 9, so I'll see you in chapter 10.